Okay, I think the numbers have stabilised. Good afternoon, everyone, and welcome to the Tyfu Cymru peat-free webinar. Great to see a lot of familiar faces joining us today. I'd like to introduce you to Barry Mulholland, Chloe Whiteside and Andrew Watson from ADAS, who will be taking the lead on today's webinar. But before I hand over, just a couple of housekeeping rules for anybody who've not joined us previously. You'll notice you're muted and off camera. We can't see or hear you. Please feel free to use the chat box down at the bottom and put any comments down there. But if you've got a specific question, if you could put those into the Q&A box, and we will deal with all the questions at the end of the session. So thank you very much, and I'll hand over to Barry.
Good afternoon, everybody. I'm just waiting for the talk to load up. I'm nearly there. Okay, so thank you very much to Tyfu for inviting us to talk to you guys this afternoon. And really, it's to tell you a bit of a journey, really, about where we've come from and where we've got to, really, as a group, but also as an industry. And we became involved with the growing media story in around 2013, but of course it's not a new story. Peat-free's been a conversation that's been bandied around and tested and trialled for many years, 20 years or so, 30 years longer. And really, we came into this equation with a backdrop of intuitive approaches to how do you create mixes that are peat-free. So what our real motivation, the reason we got involved in this really was to bring some sort of scientific structure, if you like, to the whole peat-free debate, and to actually give growers and growing media manufacturers the tools to make new and informed decisions really around the materials that are available that are not peat. A lot of that activity was going on, but as I said, it was quite intuitive really, the sorts of initiatives that were being arrived at and driven to create new products. So we came into the story sort of partway through the whole industrial process. Okay, so I'm Barry Mulholland. I was the project lead, and this is where it all started in 2013, and that project's since finished. Andrew Watson will be talking. Andrew's a modeler, he can introduce himself. And that's a really core component part of what goes on here. And Chloe was involved with others to really drive home the on-farm or the grower site implementation of the theory into practice. And that's really been a key part of our work. Does it actually work in practice? All the theory that we've come up with. It's all very well having models and numbers, but does that translate into good outcomes for growers? So I'm going to talk a little in a minute around the motivation, the drive for peat-free and why it came about. Methodology, Andrew's going to deal with that. The grower outcomes and practicality, then that's in Chloe's area, and that's across a whole range of sectors of horticulture. And we're looking at containerised production, so that goes from mushrooms through to trees. And also, finally, we'll be looking at how to get help to actually come up with mixes that are peat-free and how to do that well. Okay, so the motivation goes without any great surprise, really, to guys involved in this area. UK government and phasing out of peat. There was a target for the amateur sector, hasn't really happened, and there's a target for the professional sector by 2030. So these targets have come and gone, but we really are hurtling towards a peat-free future by 2030. And there are certain things that have happened really in recent times that really have accelerated that transition. And part of that has been zero carbon 2050. You've heard about that. I mean, we've all been encouraged to drive electric cars apparently. And then we've seen it in the energy sector where we've gone from coal to gas. And then we're looking at a whole mixture of sources now, renewables, and of course nuclear that's talked about a lot and looks very expensive. But anyway, so it's looking at a mixed economy, and I suppose that's the way things are going when you move away from traditional ways of doing things, and peat and grow media is no exception here, unfortunately or fortunately. But when I guess this whole area was looked at initially, people started to look at, well, peat-free, how can we do this? But when you start to look in, well, actually we're dependent on one material. So diversifying the market actually starts to make economic sense. In a practical sense, it's very, very challenging, the industry. But in an economic sense, to de-risk, to mitigate risk in the market and not be dependent on one material actually is quite sensible. And we've seen this with peat this year with the environmental sensitivities pushing out to Ireland, and the lack of peat harvesting. This whole peat-free scenario could come sooner than expected. It's partly driven by availability, and of course when things become more scarce or become scarce, they become a lot more expensive as well. So there's going to be some competition around the cost of peat versus other materials. So it's a good job, really. I think we've got robust ways to look at other mixes and other products out there that could replace what has been the industry standard for many, many years. And still the industry uses around 60% of the industry uses peat, but to look at other materials that are in the same price bracket and that are available. So really the idea around peat and acting as a large carbon store, that's got a lot of traction in government around Defra. It's got a lot of traction with the NGOs, and you know it's of interest across many sectors of organisations that are concerned about the environment and need to say climate change, and peat falls into this. Next slide, please. Okay, so the commercial motivation, I went over some of that in the previous slide. Yes, it is driven by government, but also consumers. Consumers expect environmental sensitivity around the products they buy. So environmentally aware consumers, and I think that's quite an important driver for where the industry could reap benefit by looking at materials other than peat anyway. Also, there's a global increase in containerised production as areas, loss of soils, they're much more efficient. Growing material in containerised systems, you get way more production per unit area. So where you've got huge population increase, then you've got the push for way more efficient growing systems. And of course, these growing systems need substrate, they need growing media, you can't use peat, so you've got to look for alternatives. I also brushed upon the mitigating risk and lessening the reliance on the single raw material. That's quite an interesting point, because the guys will go on to talk around the materials that we were tasked with mixing and using as alternatives to peat. And when you start to do the calculations on a global basis, we're not showing that data today. There just isn't enough of any one material to replace peat. So you're going to have to go for a mix. The other thing to add to that, when we started this whole process, the first thing we discovered, believe it or not, was that you can't recreate peat either. And that had been a focus of lots of materials selected to actually recreate peat, and then you've got the same type of responses and the same type of materials, the plant's responding in the same way. Well, it just doesn't work like that. All the materials we're looking at are primarily plant cell wall organic based materials, but as is the way of life, none of these materials behave in the same way. And when they're mixed, they don't behave in linear fashions either. So it's not an easy problem to solve. it's a very easy concept to mix stuff in a pot and you come up with something that may or may not work. But to do that consistently at scale for the industry to routinely turn out marketable quality products and meet our specification and orders, that's a different thing entirely. So what we're faced with really is looking at how to create mixes well, but also to create mixes that work, and also to create mixes that are affordable. So we're in a tight, low margin, well, high value but low margin industry as a rule. So anything that increases the price point by X% hits the bottom line. So this whole area of looking for alternative materials has to be price sensitive, has to fall within the ballpark of what people are used to paying around peat. Otherwise, consumers have to pay more, or somehow the supply chain has to absorb that extra cost. Best to try and keep the costs under control and keep them quite close to what we're used to as an industry. Okay, so hopefully that gives you some idea about why we've looked into this whole area and why we were tasked to do it from a scientific perspective. So I think that's my last slide, Chloe. I think so. So what I'd like to do now is hand over to Andrew, who'll go through the methodology and how we went about formulating, creating the best blends at least cost. That's the best way to leave this. Thank you very much, Andrew. Over to you.
Okay, thanks, Barry. So hopefully folk can hear me. I see there's a message or two being up on the chat about can't hear, but anyway, I just want to start off by saying that this is not a new problem by a long shot, and in some ways what we're doing is not that new, but we, I think, have got a new take on it. So using materials to dilute peat, people have been doing that a long time. Sometimes it's gone very wrong. So you get some really quite serious failures. So yes, they can hear me now. And getting to 30% of non-peat is, pretty easy. And coir is a useful material. All this we know, but the problem is where to go next from there. Okay, and the core problem is that there's not really a systematic way of, first of all, formulating an improved blend. If I have a blend which works now, how do I get to something even better? And if I have some blend in my pocket now, how does it compare to some other blend? There's not really any way of dealing with that. And another issue is that if you're going to try and do everything by trial and error using growing trials, it takes a long time and it's expensive. So the mission is to try and invent a way of short-circuiting some of this, making the whole process more systematic and with less problem, less cost. Okay, so if we could go to the next picture. Okay, so we've focused on plant-based materials, which is the peat, bark, wood fiber, coir, and green compost. The idea is to move away from the sort of recipe type formulation where you have, say, a 30% wood fiber, 70% coir. It's too vague. And this has really come to a head with the alternative materials such as the wood fibers and the barks. Things like fine peat, its properties are really quite constrained. So if I talk about my fine peat and your fine peat, we all know what we're talking about. But if I start talking about my wood fiber and your wood fiber, they can be completely different, which means that if I tell you about my recipe with 30% wood fiber, it bears no relation, perhaps, to what you've got in front of you. So it's too vague. Instead, the big idea, is to move to a description of materials in terms of its physical properties. Okay. Previous work has identified 3 physical properties as a key describer. So that's the airfill porosity, the AFP, the dry bulk density, the DBD, and the available water. And the other thing I think which we've brought to the table in this issue is some kind of a simple and informative output. There's no point in just putting out tables of numbers because it's very hard to interpret. So as we'll see later on, we have, I hope, an informative graphical output. Those 3 parameters, the AFP is just simply the amount of water that the substrate can retain. The DBD is the density, and the available water is a little different. It's related to the AFP. It's a little different though, because it's the water that the plant can actually extract from the substrate, not quite the same as the water that's trapped in the substrate. Crucially, you can use physical measurements to determine these properties. You can go to a lab and measure these things. You are not going to use plants to measure these. So we're moving away from using the plant as a detector of material well-being over to using lab measurements as a detector of the quality of the substrate. So we're not using plants as detectors anymore, we're using lab equipment. The other factor is that these properties mix fairly easily if I want to therefore take blends of raw materials with known properties. I can estimate or calculate the properties of the combinations. So let's see how this all works out. I've got my blends described in terms of 3 numbers. What this means, it sounds simple enough, but this has very serious kind of implications, because what it means now is if I have a wood fiber and coir blend which has certain set of numbers to describe it, I can say if I have a bark and green compost blend, then I can say that they are the same. Okay, and this is a game changer, because now I have a means of comparing two apparently completely disparate substrates. One is made of 2 materials, the other made of 2 different materials, and in the past it doesn't really make any sense to claim that they're the same or different. But now I've got some criteria for describing them as the same or for describing them as different. So once I've got that under my belt, and what we've done in part of the project that Barry referred to was to perform trials by plant type and by plant parameter, by substrate parameter, and we can measure out, we can map out how the different plants perform according to the 3 parameters. So this is actual experimental data. It's a 3-dimensional plot. It's a little confusing when you first see it, so we'll go through it step by step. First off, the color bar on the far right is to describe how well a plant has performed. This plant is a pansy. So blue is bad performance and the yellow is good performance. There are 3 axes. So on the plot, on the far left, we've got available water going from 0 to 40. Then pretty much along the bottom, we've got airfill porosity going from 0 to 60. And then kind of into the page, hiding behind the color bar, is the density, the dry bulk density. There are 19 materials here altogether, and they've got, well, 20 including peat. The substrate properties are all measured, and the 3 numbers give locations to the dots. The color of the dots is how well the plant performed. Okay, so in this case, a pansy. We've done this for other plants. So what you see is the blue blobs, the blue dots, are all kind of in the corner in the front. That means materials with those properties are poor performers. The yellow is good performer. The black ringed number 1 is peat, which is it turns out to be a good performer, but there are others also yellow, which are adequate performers. Their properties are not the same as peat. You can't get to peat, basically, with the materials that we've seen, but you can get performance which is close to peat. So what you're seeing here is a graduation from the blues in the front corner to the yellows in the far sort of upper corner. And that gives you a clue that there's a trend here that we can pick up and work with. And I should say that all the other plant types show broadly the same sort of pattern, and the detail is different from plant to plant. So now I've got 2 things. I've got a trend, I've got a way of showing how I get a better performance. So if I've got something in the blue, I need a higher AW and a lower AFP to project myself into the yellow region. So I've got a direction clue. And I've also got a means of comparing things. So for example, in the middle, there's 3 blobs of comparable sort of green color, 11, 3, and 13. Those are totally different blends, but in terms of performance, they are basically the same. Okay, so we'll take this idea of having a trend which goes from the blue up to the yellow, and we'll sort of work with that. And we are going to use that as the next slide, please. That's what I've just said already, sorry. Next slide. So this takes that same color coding and puts it in a form which is easier to see. So to lead through this, and it's explained in the notes a little bit more carefully, this is a bark, a wood fiber, and a coir mix. And the color is the same color we just saw showing plant performance. So what you've got here is the corner on the bottom left is 100% coir, and the orange is, surprise, surprise, is giving you best performance. Running along the bottom, I'm going from 0 bark to 100% bark on the right-hand lower corner, which is the poor performer. Going up the side, I've got to 100% wood fiber, which is the worst performer of the three. The colors in the interior are all possible three-way mixes of these three materials. I can take different materials and combine them in as threesomes or as, in pairs, and I can calculate the properties for all of the mixtures in terms of the plant performance. So now I've got a means of looking at this color-coded triangle, and I can see straight away where my good performance is coming from and where the poor performance is going to lie. So this is what we're talking about in terms of graphical output. So obviously the yellow areas down the bottom there, that's the good performer, but it may of course be expensive or hard to achieve. But then for a different plant, the color balance in the triangle will change. So for example, for pansies, they're quite hard to please. So it's going to be a little tiny corner with the orange color. For a tree, there's going to be a much more sort of, a much larger yellowy color because they're easier to please. Okay, can we have the next picture? So this is the interface for the software that we've written as part of the project. And this is to show what the software actually looks like on the screen. On the left-hand side, you've got a drop-down menu or three windows where you can select your different materials. There's a number of barks and coirs and wood fibers shown there. So you pick each of those, then you pick a plant of your choice. The screen comes up showing the response triangle, which is the thing we just saw, and next to it is the price triangle. Now, I should say that the numbers in there are totally fabricated because at the time I didn't have any price data, and that's commercially sensitive anyway. But the point is that each spot in the triangle maps to a corresponding spot in its neighboring triangle. So I can compare the cost directly with the plant performance, and I can make some sort of an informed judgment about whether or not the cost is worthy of the performance hit. Okay, so that's what it actually looks like. So we're not the first to do this, but to start speaking in terms of parameters, but I think we have taken it further. We've certainly the only ones to have generated a graphical, what type of wood fiber? There's a message come up. There's a whole host of wood fibers under there. So I don't know which one it is. I just picked one at random. The graphical interface is supposed to provide an easy interpretation. I've shown media cost, but other factors such as the sustainability index and other things could also be thrown in as other triangles. So again, spot by spot, they can be compared. And I should point out, we're only looking at physical properties. Other aspects are important, but they can be modified in ways that the physical properties can't. You know, you can paint the color, change the color of the front door of your house, but you can't move your house. Okay, next, please. That's you, Chloe.
Yes, moving over to me. Thank you, Andrew. So I'm now going to talk you through some of the outcomes from the trials that we did on commercial sites over the last 5 years, and just really kind of talk about what does it mean for you as a grower when using these peat-free materials on your nursery, and what practicalities do you need to consider if you're going to be changing from a very high peat mix to something that's peat reduced or peat free. Now you can see an image of some viburnums there, but we did do trials on a whole range of different sites using all different types of crops, as Barry alluded to at the start of the presentation. So not just hardy nursery stock, but bedding and pot plants, pot grown herbs, propagation for soft fruit, salads and vegetables, longer term fruit crops such as containerised apples and cherry trees. So a whole range of different crops with different needs, different areas of the country, and also different growing systems and irrigation methods. So we were looking at sub-irrigation through ebb and flood, overhead irrigation, drippers. So really trying to spread the research as far as we could and look at a whole different range of species and growing types to really see how these materials would perform in a commercial setting. Now, one thing I should also point out is that we did a whole series of preliminary experiments at our site in Cambridgeshire beforehand, so we could narrow down from the predictions from the model blends that we could take onto a commercial holding that would have some promise, and then really look at those in more detail, rather than taking a whole wide range of materials out onto a nursery and then getting some that just didn't work. That wasn't going to be of any benefit to us or to the host growers. So we narrowed it down to the ones that really did have potential before we went out onto the grower sites. So looking back at these pictures of viburnum, so this was from a trial that we had at James Coles in Leicestershire in 2019. And I just asked, can you pick out which is the nursery standard? The nursery standard being a peat reduced material and all the others being grown in peat-free blends. And I think it's fair to say that actually looking at that picture, it really is quite difficult to pinpoint which is the standard and which are all the experimental blends. And you can see a few slight differences there, with the fourth picture being quite taller than, the fourth plant being quite taller than the others. The third one perhaps being a little bit on the shorter side. But really, what you're looking at is a whole range of crops that would be marketable. And from the grower's point of view, he would have been able to market all of those without any issues. So here we can see those plants again. The leftmost plant is actually the peat reduced nursery standard. Then if we go from the left, plants 2 and 3 are quite coir rich, obviously no peat. And then plants 4, 5 and 6, no peat, but also no coir. And coir has kind of been seen as one of those materials that's quite easy to switch to. So go from peat-based materials to coir-based materials. And yes, it does work, but again, that's a reliance on a single raw material, as Barry mentioned at the start. And we're trying to move away from that reliance on individual raw materials and look at a whole range of different things. So having promising blends that have got no peat and no coir in them either was really encouraging to see. And this wasn't just on the hardy nursery stock trial in 2019, but on a range of different crops within that year. This particular trial was actually looking at what we called novel materials. So they were materials that weren't necessarily new to the industry, but were new to us as a project team. So we didn't have prior experience of using them, and we purely went on how they performed from a modelling perspective, where their parameters fell within that model, created blends, and then took those out into the nursery. So it was really kind of putting the model to the test in this final year. And the results that we were getting from James Coles and from other nurseries were really very encouraging. I can show you this picture here. So this is commercial pot chrysanthemum grown at HH down in Hampshire. So this was also from 2019, and this was using the same blends as the viburnum. So the photograph here is basically going across one of the ebb and flood benches, and you can see just how even that crop is in terms of the height, but also in terms of the flowering. So what we were seeing here was a range of different blends that all produced a marketable crop which flowered at the same time. And that was really quite crucial when you're marketing to particular dates and need to have your crop ready by a certain time. Then that was really key that we had those flowers there in time, and also the number of flowers as well. So we weren't seeing any reductions in the numbers of flowers, and we weren't seeing any delays in the flowering time. And you can see from that image that we've got nice even colour and a good even crop height. One thing I should also mention about this trial is that we actually filled these pots on the machine at the nursery. Sometimes when you're doing these trials, it's not always possible to use the kit that they have on the nursery that they would normally use to fill the pots, because obviously we're in a commercial setting. People need to be keeping those machines going and filling their own pots and getting their own plants out onto the nursery. So quite often it's very, very time consuming for somebody, for a grower, to have to empty that machine out for us to put our blends in and get it all through and get the pots filled. But we were able to do that at this nursery, and I will come back to talk about mechanisation and machinery a little bit later on. One thing I want to show you here is this graph. I'm not going to dwell on all of the results from all of the 5 years of the trials, but one thing that Andrew mentioned with the modelling presentation was that we were starting to pick up on fresh weight of the blends, of the plants, because that's really something that isn't subjective. So a quality assessment is quite a subjective view, but the fresh weight of a plant is something that you can't argue with. It is what it is. And so we were then using fresh weight to populate the model and give us the best data and the best outcomes from the model. So this is looking at the chrysanthemum at the end of the trial, with the fresh weight on the vertical axis there, and then the blends along the bottom, along the horizontal axis. So you can see which bar is the nursery standard, and then the others are just coded prototype numbers, because for commercial reasons we kept the prototypes as an anonymous blend. So what you can see if you look at this graph is that there are some differences in the fresh weight. So the letters above the bars basically indicate significant differences, and that's important for us in terms of the science and the results, that we can pinpoint and see these significant differences. So what you can see is that if there's a letter C, then basically that's significantly higher than anything else, and that's showing as the nursery standard. But if you look actually at the differences in the fresh weight there between the nursery standard and say prototype 5, in reality you're looking at about a 10-gram difference. And the reality of this trial was that regardless of those differences in the weight, which were coming out as significant, from a commercial point of view, all of those plants were commercially acceptable and marketable. So it's useful for us, for the model, to be able to pick out those differences, but also we then have to look at the real life situation and what are the growers expecting. And really any of those blends would have been useful for the grower to be growing his commercial crop, because at the end of the day, they were all given a marketable product. So that's just some way of highlighting to you the sorts of things that we were looking at and the data that we were looking at in order to build the model. Now, I just mentioned earlier that we did extensive trials work, which looked at a range of crop types and different irrigation systems. I just wanted to show you a few of the images from those trials, because we've got really very different crops, each of their specific needs, but it was clear within all of those trials that you can produce a commercial crop in peat-free blends if you get the right blend for that crop type and that growing situation. So you can see the images here where we've got herbs on ebb and flood benches, we've got hardy nursery stock outside on mypex with overhead irrigation, we've got pack-grown pansies, we've got strawberries in troughs with drippers. We might think, why strawberries? Because they're already grown in coir. And again, that's coming back to the over-reliance on a single raw material. And moving forwards, potentially in soft fruit production, they're going to have to start looking at different blends and different alternatives to just coir. And then at the top there, we have young cherry trees in containerised, in containers with drippers. So it just shows you a little snapshot of the different trials that we were doing. So in terms of some of the practicalities, first of all, we'll touch on irrigation. So this really is very, very important. If you're moving from peat, which a lot of people have learned how to manage peat, how to manage the irrigation, if you then suddenly switch to peat-free, it really is a little bit of a learning curve, and you need to take the time to actually learn again how to irrigate that crop, because the material, the peat-free material, will behave very differently. And quite often what we were finding in our trials, that was a little and often approach to watering was a lot more beneficial than a heavy irrigation, and then leaving the crop for a long period of time and then going back in again with another heavy irrigation. So what we were seeing was that little and often approach tended to be more beneficial. Another thing that we've also kind of learnt to accept when we're growing in peat is that if you look at the plants and you see that the top of the peat is dry on the top of the container, then we know that, okay, that looks dry, we need to water it. But it's not really the same with peat free. So don't be misled by a dry pot surface. Often what you'll find is that it's very dry on the top, but when you lift that pot up or you poke down into the media, it's still really quite damp. So you can then sometimes run the risk of actually overwatering, and then that may come with issues with rooting and root disease. So don't just assume that because the surface is dry, that the rest of the pot is dry. What we have also noticed though is the fact that because those pots tend to stay drier on the top, then that is actually quite useful when it comes to controlling things like moss and liverwort and other weeds, particularly in longer term hardy nursery crop stock. So particularly where we've had trials outside before, where obviously they're open to the elements and you may have some really heavy periods of rain or prolonged rain. Whereas sometimes you might start to see liverwort developing in some of those crops. With our peat-free blends, we were seeing less of that because of the fact that they do tend to start drying out on the top a bit sooner. So there is a benefit as well for, to have the surface remaining drier. And you really just need to start learning how the media behaves throughout the season, particularly with such fluctuating temperatures where we can get really high temperatures for a few days in the summer and then it might suddenly get cooler again and then it goes back to being high. So I said it before, but we just have to start to learn how to manage the irrigation and get the full potential out of these blends. One thing that you can do is look into weigh containers to begin with. So then you can start to figure out kind of recognizing when pots are too wet or too dry. And that's also quite a useful technique for if you have new growers or a new person on the nursery who's going to be doing the watering, then it's quite a useful technique getting them to weigh pots to figure out when's the optimum time to irrigate. Really is quite useful, and it might seem a bit time consuming to begin with, but in the long term it really is a benefit both to that person that's going to be doing the watering but also to growing the crop. In terms of nutrition, what we did with our trials was to analyse all of our blends before we used them, so that then we had a good idea of what was already there, and then we could tailor the nutrition accordingly so that we were starting out on an even playing field in terms of nutrition with using these different blends. And it's really important to carry out a nutritional analysis on your new batches of growing media anyway, just to ensure that your feeding regime is going to correspond to the needs of the crop, but also just to make sure that everything is okay with that batch. Most of the time it's going to be absolutely fine, but just getting that nutritional analysis carried out at the start just gives you that little bit of extra buffer of making sure that everything is all right. It's important to monitor the pH, the acidity, and the EC, the electrical conductivity, throughout the growth cycle, particularly if you've got a longer term crop, so something containerised hardy nursery stock, for example, something that's going to be on the nursery for quite a while. If you start to see that your EC is getting too high, then this can result in plant injury or loss. If your pH is too low, then there's various macronutrients such as nitrogen, which can become less readily available. You'll start to notice that with the older leaves, where they'll start to kind of turn yellow and look deficient. And on the opposite, if the pH is too high, then some micronutrients such as iron can become unavailable to plants. So that's when you start to see the young leaves turning white. And really, if you're monitoring on a regular basis, you're really trying to kind of preempt anything happening which could be detrimental to the plant. So if you're monitoring routinely, then you should hopefully be able to pick up any differences in the nutritional composition or the pH or the EC of your growing media before you notice it in your plants. Because if you notice it at that early stage, then you can rectify it before something happens to the plant. If something then happens to the plant, then you probably can rectify that by liquid feed or various means that you can do to kind of benefit that plant and improve it. But if you can prevent it in the first place, then not only is that better for the crop, but from a financial point of view as well, that's going to save you on money and save you on time. So routine monitoring really is quite important, just to monitor the nutrition. And it's worth pointing out as well that when you're moving from peat to peat free, it can take a little while to kind of get the most out of that and get the nutrition right. So when you first move to a new blend, then it really is important to keep monitoring. With mechanisation, I mentioned this a little bit earlier with the Double H trial and the fact that we were able to use the potting machine there. We also did some work within this project purely on mechanisation. So we were looking at the various blends that we used on the growers' nurseries, and we were looking at how they would go through pot filling machines and also tray filling machines of various sizes. So from really quite large cells, 84 cell trays, down to the kind of 3, 4, 5 cells, which you would use in more of the propagation. So we were looking to see, did we need to make many changes to the machine? Would the blend flow continuously through the machine without any blockages or without any issues with actual filling the pots or the trays? Generally, what we found was that we had to make very few changes to those to the machinery. So if you are moving to a peat-free blend, then it doesn't necessarily mean that you've got to suddenly change all your machinery, but you will want to just kind of play around with it a bit and tweak things to really kind of get the most out of it. Make sure that those pots are filling correctly, make sure that there's enough in there so that over time the pots aren't actually going to start slumping because there is a bit too much air in there to begin with, but also making sure that they're not going to be over-filled and push all of that air out. What we tended to see was that with the more fibrous materials, then they're not really ideal anyway for trays, and there were some issues with filling trays, but that's something that you would work with your growing media manufacturer to work out the best blend that you could use in order to be able to fill trays, a small celled tray, easily and consistently without any problems occurring. So generally, what we tended to see was it was the more fibrous blends that required slight adjustments, mainly just to make sure that things weren't starting to block up within that machine. But with everything else, we didn't have any issues with those going through the machines. And as I mentioned with the Double H trial, all of those pots were filled using their machinery, and we didn't have any issues throughout the trial with those pots. One final thing to touch on is the pests, diseases and weeds. So generally, if a growing media blend is well managed, then there shouldn't be any major issues. We didn't have any problems occurring throughout the trial with any pests or diseases. I touched on the weed thing a little while ago. So with the pots remaining drier on the surface was actually reducing the issue of weeds. Sometimes if you've got the materials with a high available water, then you may get root zone problems such as root rots, Pythium and Phytophthora, or through sea arid and shorefly larvae feeding on the roots. But if you have that material within a blend of other materials, then that's really going to reduce that risk, because you're going to put other materials in that are going to give a good structure, they're going to bring the air in. And so that's why we're looking at creating blends. We're not just looking at individual raw materials. If you include other materials with lower available water contents and careful irrigation management, then using those materials with a higher available water are still beneficial to your crop. So it's just really working out percentages through the model of how you can create that blend and get that optimum blend for your crop. So this slide here, getting help. So the predictive modelling assumes that the media properties are measured. So as Andrew said in his presentation, the properties can be measured through lab techniques, which is what we did at ADAS for the duration of this project. But then the outcomes do still need some kind of validation via growing trials. So by using this model, we're not saying that that takes away the whole trial process, but what it does do is short circuit it and narrow it down, narrow that window, so that you can move from creating blends to getting blends out to market a lot quicker. So we have what's called the ADAS Growing Media Service. That encapsulates parameter measurement, trial setup, and data evaluation. We have a website, which you can see on the bottom of this slide. And by going through that service, that enables you to be able to utilize the model and to develop the blends that are going to be most suitable for the crop. One thing that I would like to just acknowledge is that the work that we did over the 5 years to create this model and to look at the different blends on the different grower sites was all supported by Defra, the AHDB Horticulture, and very heavily by the industry, so by both growing media manufacturers and growers. So just to acknowledge their input and thank them for their input into the work over the last 5 years. And that brings us to the end of our presentation and hopefully questions, Sarah.
Thank you, Andrew, Chloe and Barry. One of the questions that's come through, I think it's back to Andrew's part. What type of wood fibre is represented by the blue?
Okay, we measured something like, I forget the number, 80 or 90 different materials and lots of wood fibres amongst them. And you'll sort of, on those drop-down menus, you can see just how many there were. I just picked the first one, and so I actually don't know. And even if I did know, I wouldn't say because it's commercially sensitive. So I'm very sorry about that. But in a sense, it's not really terribly relevant. A lot of the wood fibres, in terms of the where they appeared in the modelling, a lot of the wood fibres performed poorly.
Thank you. Thanks, Andrew. Another attendee has asked, have we allocated basis points to this webinar?
Pass.
I don't understand what that means.
I will look into that and come back to you. If you could, if you wanted to email me direct, I'll find out for you, and I'll put that on the, I'll put my email address on the chat bar now. Great. And a grower earlier came up with the question for all of you, I guess. Is there enough alternative growing media available to replace the peat? And will the alternatives cost more for growers?
I guess I can answer that question. I think the simple answer is no, there isn't. Globally, there just isn't enough of any single other material to replace peat. So we're in competition not only from other parts of the world, namely sort of Asia's growing very quickly, China, the demand's gone through the roof and it's going to get higher and higher. A lot of the materials we're talking about, things like coir come from Asia, that part of the world. So there's immense competition, which only means one thing, that the price will go up. The other competition comes from the energy sector. So things like wood fibre, wood products, they're going into burning for, if you've got a biofuel burner in your nursery, or if you run Drax, it's wood chip. It's you've got competition there, so that's going to drive prices higher again. So this is the whole rationale behind why we're looking at recycling materials, why we're looking at mixes, because this whole area is going to be price sensitive. So if we have got 5 or 6 alternative mixes, and one year everything's nice and affordable, next year 2, 3 of those might be really, really expensive. You've always got a fallback position. If you're dealing with one material, then you've just got to go with it, whether it's expensive or cheap. So that's the situation that we're in. So I could dig out the information, the data, but basically there isn't enough of the known alternatives, such as coir in particular, to go around and satiate need, not even for Europe if we went to coir. So never mind competition from the rest of the world. And containerised production, it's just going to become more and more popular, more and more widespread as people seek to become more sustainable and more efficient in their growing systems. Do you want to add anything else, Andrew or Chloe, to that? Or?
Not especially. It is just interesting what the lack of peat harvest in Ireland has sort of exposed the problems of relying on a single material, and also, of course, the whole issue surrounding peat.
Next question, thank you for that. Is the calculation model available for growers, substrate manufacturers in the future, or when will it be available?
That's one for Barry.
I thought it was one for you, Andrew. Okay. Well, we run the service, and the whole idea of the service is that to run the model, you need particular data. So we've got an ADAS, a standard operating procedure around alternatives. When we started this project, I think the first thing we realised was that there wasn't a standard there. There were SEN standards for materials, soils, and other things, but there weren't necessarily standards or standard operating procedures for the materials that we were tasked with looking at. So we created our own SOP to actually work on small amounts of materials. There are commercial tests available, British standards and SEN, for example, for bulk handling of raw materials, but not for small samples that we were looking at to actually test and parameterize the model with. But it turned into a standing operating procedure, and that is freely available on the ADAS website. If you plug in laboratory methods for growing media, it'll go straight to a PDF, and it's got all the techniques around airfield processing and everything that we've done there. In terms of the actual service, so that's important, that we need to get the right type of data in to actually get the right answers out from the model. So what happened within the project, we actually, within the 5 years, we went to a product. We went to something that the industry could actually use. So we didn't do the project to get another project. We did it as a means to an end to actually expedite this whole process. So what we've done, we've commercialized this whole solution that we've developed, and to actually commercialize that, then it's a paid for service. So you can pay for, I'm not saying the prices now, but if you engage with conversation with ADAS growing media, then we can provide quotes. But we would provide analysis. We'd provide with that, if you wanted it, the modelling service to actually design new blends. If you use the service, if you pay to get samples through, then versions of the model can be released as part of that service to end users, to growing media manufacturers, growers, whoever wants to use that. But you would have to engage, you would have to pay as part of that arrangement to actually use that and get access to that model. So it's not a freely available thing, the actual model itself, because what you do need with it is support, guidance from Andrew, who actually created the model. So it's a service where we're looking to develop products with the user, with the end user. It's anonymized and it's bespoke to that particular end user, because what we worked out straight away is that, yes, the industry is reasonably conservative in the raw material streams that it accesses, but everybody's got their own raw material streams and their own blends. So when we actually went about this whole process, we had access to 80% of the growing media market in the UK and the materials that they use, but we were allowed to pick any of those materials to create mixes. Not one company was able to recreate any of those mixes. So the idea was to create this model. So you had an opportunity to create the best blends for least cost for your business. So it's a bespoke tool, and we're offering that service. So we've broken it down into modules. We've got a service there. You come out the other end, you design the blend, design the trials, the data analysis, and so on and so forth. But it just moves away from intuitive mixing. It goes straight through to high performing blends and actually analysing the data to show that, and robust data, so that really, really sound business decisions can be made around new product development, going peat free, and actually taking that uncertainty away from if your raw material streams completely change from one year to the next. You can use the model to, at the point of manufacture, to actually work out what the mixes and ratios could be. So we just see numbers. These are parameters, and these actually inform good, high performing blends. We're not engaged with the part where guys are sourcing raw materials and all the rest of it. That's not our business. Our business is to help assist and generate and short circuit and reduce costs, improve efficiency of that whole process. If you want to engage with the service, if you don't, fine. But it's a service that's out there, and we know by working with the industry closely, it's accurate, it's useful, and it's timely.
Okay, can I just add something to that, Sarah, if you don't mind?
Yes, sure, go.
Yeah.
Please do.
All I just wanted to say was that the model, without the numbers to put into it, is not useful to anybody. Any kind of a predictive model, ours or anybody else's, should they come up with one, has the same issue, that it needs input data. Also, I'd just like to observe that if you had the model and you fed in values that were accumulated in the incorrect way, it would give false answers, and that's a bad thing. Okay.
Great, thank you both. What about the peat phasing out targets? If the amateur phase out was planned to be in 2020, could you talk us through that, please?
Well, it's not law. It's something that government are pushing for. But if for example, we'll focus on the commercial, because that's the bit that we've actually been tasked with sorting out. If you focus on that, then there's a Peat paper coming out later this year in 2020. That will have some more information about the direction of travel for government, but certainly the direction of travel is one of zero carbon 2050. So if there's not enough progress being made, I mean, still 60-70% of the growing media used by the industry is peat. If that doesn't change significantly over the next few years, then in Defra would, I suspect, look at different types of measures to actually try and expedite that process. They've basically paid out for this research. They paid out for the development of an industry tool. I guess from where they are situated, they'd quite like to see that used to actually move the industry towards reducing peat. So the tools are out there, and we know peat-free can work. It's about how fast we move towards the target.
Thank you. And taking on board what you said about the model, Barry, will any of the model information be available to consumers in garden centres?
No, well, we're dealing with the commercial sector, so that would probably be a no, because the costs would be prohibitive to that for most people.
Thank you. Any more questions? Oh, Andrew, you mentioned before the peat harvest. Could you explain to us what's happened this year?
There's a long and convoluted story involving a legal challenge on environmental grounds to the peat harvest in Ireland, and I would not claim to be an expert on that, but my understanding is that the harvest was essentially foregone because of the legal challenge, and there's been little or no harvest within Ireland this past season, and the industry has been relying on stockpile material, and don't take that as gospel, but that's that's my understanding. And it's also to the untrained eye, you might think, well, and that includes me, well, why not get your peat from someplace else? And you know, the Baltic peats, and apparently that is not so straightforward because the properties are different, and you come back right straight back to the need for some sort of a modeling tool to allow you to incorporate, for example, a Baltic peat instead of an Irish peat to get to your finished product. But the bottom line, to answer your question, there's been a legal challenge on environmental grounds which has halted the peat or significantly reduced the peat production in Ireland this past season. Hopefully I got that right, Barry, if you want to comment.
That sounds, no, that's, well, the other thing is that if you're working on stockpiles without any future reserves, then the price will go up.
Thank you both. I know Charles has put in the chat, that would be very interesting. Thanks, Charles. Any of the attendees using peat-free media, and what experiences have you had? So please do feel free. Emma's saying, I'm using Melcourt Organic and Melcourt Sustainable. It's great, except the nutrients isn't long lasting, especially in the organic CC. And any other questions before we wrap up for our panelists? I hope I haven't missed any. Just give it another couple of minutes. I think that's all, and that's about just after 1 o'clock, so that's great timing. And thank you very much to Andrew, Chloe and Barry for a really informative webinar. That was really, and thank you all the attendees for your questions. So thanks for attending. If you'd like any more information about our project Tyfu Cymru, please do get in touch via the website. It's 100% funded training and development for horticultural businesses in Wales, and we'll post this webinar on that website within the next few days. When you leave today's webinar, there's a short evaluation form to complete. We'd really appreciate it if you could just spend a couple of minutes letting us know your thoughts and perhaps suggest topics for future webinars. So thank you once again to our panelists, and thank you to everyone for attending. Have a good day.
Thank you.
Thank you.